Hello friends, today we are going to study on the topic of collision. So the first thing we need to understand what is a collision. So the collision is nothing but when two objects collide each other, they exert relatively strong forces on each other and for a relatively short period of time. So to do the collision, two objects must be necessary. So the example for a collision is one is playing of a billiard balls. In this billiard ball, one ball is hitting to another ball. So this is another example of collision. So here the sharing of the forces between the balls occurs, and another example is carom board. So here the carom coins hitting one together, and here also the sharing of the forces occurs, and another one is hammer striking the nail. So these are the three main example for the collision. So in this collision, there are two types. One is elastic collision and another one is inelastic collision. So the elastic collision, so here in the collision, one more important thing is the physical contact between the two objects is not necessary, because alpha particle, when we take alpha particle, they are moving towards the nucleus. Then because of the electrostatic repulsion, they starts to move away from that nucleus. So alpha particle, when moving towards the nucleus, because of the electrostatic repulsion force, they move away. Electrostatic repulsion force, they move away from the nucleus. So this is also, we are calling it as the collision. They move away from the nucleus. So this we are also considering the alpha particle has undergone the collision with the nucleus. So here there is no physical contact between the molecules. There is no physical contact between the molecules. So here the main thing is we need to understand the forces involved in the collision. So we have to understand the forces involved between the collision, so that we are obtained only by knowing the status of the object, so where the position of the object after the collision. So with the help of that, we can find out how much force they are interchanging. So these collision are classified into two types. So this classification has done. So the first one is elastic collision and another one is inelastic collision. So elastic collision is nothing but there is no loss of kinetic energy here. So in this elastic collision, there is no loss of kinetic energy. So no loss of kinetic energy here, and here there is some loss of kinetic energy. There is some loss of kinetic energy. So during the collision, if a linear momentum of the object is conserved, linear momentum is conserved, and total energy is also conserved, total energy is conserved, and kinetic energy is also conserved. And one more thing is, whatever the forces are involved in the elastic collision, so they are all conservative forces. So forces involved in the elastic collision are conservative forces. So they are not dependent conservative forces. So they are the path dependent. So these are the main characteristics feature of the elastic collision. And in this inelastic collision, a linear momentum is conserved, total energy is also conserved, total energy is also conserved, but there is a loss of kinetic energy. So there is a loss of kinetic energy, means kinetic energy is not conserved here. Kinetic energy is not conserved here. It's not conserved here, and whatever the forces are involved, they are not conservative forces. So forces are not conservative forces. And while studying these things, the main important point is, whatever the collision we are studying, so we need to consider that the system must be isolated. System must be isolated means there shouldn't be exchange of any masses between the two objects. So even we are not considering any external forces also, but we are taking gravitational force and some other forces, or we are just neglecting. So this is the main thing. System must be isolated to understand, to study this collision, even that elastic collision and as well as the inelastic collision. So in this today's lecture, we are only focusing about the elastic collision. So we are going to derive the elastic collision. So to do this, what I will take is, I need to take two objects, and these two objects need to collide each other. So today we will derive the expression for elastic collision for the one dimension. So the main heading of this is elastic collision in one dimension. So we are focusing only on a x-axis here. See, consider there is a one object which is having a mass m1, and there is second object which is having a mass m2. So first, initially they are both are moving in a straight line. They are both are moving in a along the x axis. So to make a collision, what is important here is, this mass m1 is moving with the velocity u1, and this mass m2 is moving with the velocity u2. So to make a collision, the condition must be u1 must be greater than u2, then only the object will collide each other. So after some traveling the distance, m1 and m2 will make a collision here. So m1 and m2 are made some collision. So after this collision, they shouldn't be in a coupled position. So again what will happen is these molecules make a movement here. So this again this m1 object will come here, sorry. So after collision, consider this is my m1 object and this is my m2 object. So after collision the velocity changes to v1 and this velocity changes to v2. So after the collision a velocity will becomes like this, v2 is greater than v1. So here we are considering, just to make a quick recap, we are discussing only on a elastic collision in a one dimension. So here I have taken one mass of the object which is having a mass m1 and initially which is moving with a velocity u1, and there is another mass m2 object which is moving with a velocity u2. They both are moving along the x-axis, and after traveling some distance they are making the collision. And to make a collision the condition must be that this first object has to move with a higher velocity as compared to second object. So u1 must be greater than the u2. So after collision again they are moving back, means they are moving with some different velocities. So this m1 object is moving with the velocity v1 and m2 object is moving with the velocity v2. So now see, we all know that a linear momentum is conserved in the elastic collision. So linear momentum is conserved in the elastic collision. So this m1 object has a linear momentum is m1 u1 and this object is having a linear momentum m2 u2, and after collision they are separated, and now this becomes m1 v1 linear momentum and this object has the linear momentum m2 v2. And initially before collision the kinetic energy of this ball becomes half m1 u1 square, and kinetic energy of this object will becomes half m2 u2 square, and kinetic energy of after collision, kinetic energy of the first ball is m1 v1 square and kinetic energy of the second ball is half m2 v2 square. So we know that a linear momentum is conserved here, means a linear momentum before collision is equal to linear momentum after collision. So my equation will become, so linear momentum before collision is the first object is m1 plus u1 and the second object is linear momentum m2 u2, and after collision the linear momentum becomes m1 v1 and linear momentum of the second object becomes m2 v2. The similarly what we can make a statement is like the total kinetic energy is conserved. So total kinetic energy is conserved in the elastic collision, so is conserved. So kinetic energy before collision is equal to kinetic energy after collision. So this equation I am mentioning it as a equation number 1. So kinetic energy, total kinetic energy before collision, we are taking about total kinetic energy. So this becomes half m1 v u1 square, not v1 square, because v1 is representing after collision. So half m1 u1 square plus half m2 u2 square and here half m1 v1 square plus half m2 v2 square. And one more good thing here is 1 by 2 is common in all the cases, and I am glad to cancel all these 1 by 2 in this equation. So this I am calling it as a equation number 2. And there is a one more term here, one more new concept to study this. So that is a coefficient of restitution. Coefficient of restitution. So this is nothing but the ratio of elastic collision before separation. Uh, this is a ratio of relative velocity after collision. So this is relative velocity after collision, and next is, oh sorry, divided by relative velocity after collision. So first we need to find out the relative velocity after collision. So between these two balls, see m1 and m2 after collision, so they are having a velocity v1 and they are having a velocity v2. So here the v2 velocity becomes higher as compared to v1 velocity, so the relative velocity between these two ball will becomes v2 minus v1. So this is a after collision, and here the relative velocity between the objects before the collision. So here they will becomes u1 minus u2. So just substitute these two values in a coefficient of restitution, that is E. So this E becomes v2 minus v1 is equal to u1 minus u2. And we know that for a perfectly elastic collision this E value will be 1. So for a perfectly elastic collision E value will be 1. So v2 minus v1 is equal to u1 minus u2. So after cross multiplication what I will get is u1 minus u2 is equal to v2 minus v1. So this is for perfectly elastic collision. So this I can calling it as a equation number 3. So now with the help of equation number 3, see the main thing is we need to find out a velocity of a first object, velocity of a first object, and second is velocity of a second object. See, because collision after collision the forces involved between them is interchanged. So because of that what is happening, the velocity of the object masses, velocity of the different object are changing. So this m1 becomes v1 and m2 becomes v2. So we need to find out the value of v1 and value of v2. So we need to focus on these two things. So with the help of these three equations, so we can find out the value of v1 as well as the v2. So first what we will do is, first we will calculate the v1. So to calculate v1 means velocity of first object, velocity of the first object that is having a mass m1. So we are finding that one with the help of these three equations. So now there is maths involved, so only little amount of physics involved. So the first is with the help of this equation number 3, I am rewriting u1 minus u2 is equal to v2 minus v1. So I need to find out a v1. So what I will do is I will take a v2 is equal to, so this v1 goes this side, so this become a plus, so u1 minus u2 plus v1. So this I am putting in a equation number 1. So my equation number 1 is nothing but m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So in this equation I am putting the value of v2. So now what it will come, m1 u1 plus m2 u2, so this will becomes m1 v1 and m2 v2. So instead of v2 what I can write is u1 minus u2 plus v1. So now only the mathematical equations, because we need to find out only the value of v1. So I will keep LHS as it is. Since this m1 v1 I will simplify, this m2 is multiplied to u1, so this will become m2 u1 and minus m2 u2 and plus m2 v1. So this LHS is m1 u1 plus m2 u2. So now what I will do is I will keep this m1 v1 and m2 v1 in the RHS, and all other terms I am just crossing here. So then what it will come is m1 u1 plus m2 u2, this will becomes minus m2 u1 plus m2 u2. So this will becomes, now this RHS will becomes m1 v1 plus m2 v1. Oh, now next here m1 u1 m2 u2 and minus m2 u1 plus m2 u2 is there. So this there is a 2 m2 u2 here, this is a m2 u2 and here is also m2 u2 there. So just add them, and here m1 u1 minus m2 u1, in this case u1 is common. So what I will do is I will take a u1 common here. So this my equation becomes m1 minus m2, and here 2 m2 u2 will come, and here I will take a v1 as a common, so m1 plus m2. So I will just uh, simplify this equation. So then what will come is this will goes to LHS side m1 plus m2, so they will become a denominator. So my equation will becomes u1 m1 minus m2, so this is divided by m1 plus m2 plus 2 m2 u2 divided by m1 plus m2. So now my equation will becomes v1. So this v1 depends on the parameter of mass of the first object and mass of the second object and initial velocity of the first object and initial velocity of the second object. So this is the main equation for to find out the velocity of the first object after collision, and the same procedure we need to follow in order to find the velocity of the second object. So now we need to find out the value of v2 with the same procedure. So we need to find the value of v2. So this v2 is nothing but it is relating to mass of the second object and after collision. So from the coefficient of restitution we know that u1 minus u2 is equal to v2 minus v1. So to find a v2, what I will take is I will take the value of v1. So I will reshuffle this equation. So I will send this v1 on LHS side. So what it will come is u1, sorry, we need to find out a v2. So I need a values of v1. So v1 I will send this side. So this v1 will becomes a plus here, and v2 will be remains this side, and this u1 minus u2 interchanging. So this plus u1 becomes minus u1 and minus u2 becomes plus u2. So I will substitute this equation in equation number 1. So my equation number 1 is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So this is my first equation. So here what I will do is I will substitute the value of v1. So this will becomes v2 minus u1 plus u2 plus m2 v2. So m1 u1 plus m2 u2. So this is m2 u2. Now I will multiply this thing. So m1 v2 minus m1 u1 plus m1 u2 plus m2 u2, and this will becomes m1 u1 plus m2 u2. So now I will interchange the term. So I want a v2. So v2 I am keeping v2 on RHS side, and other terms I am sending in the LHS side. So m1 u1 and m2 u2 as it is. So I am sending this minus m1 u1. So this will become a plus m1 u1, and next m1 u2. So this is coming this side. So this become a minus m1 u2. So this will be comes next. Sorry. Okay, m1 v2. Okay, this one is v2. I have this is m2 v2. So this is m1 v2 plus m2 v2. And here now m1 u1 and m2 u2, there are two m1 u1, and so by adding this thing what I will get is 2 m1 u1 plus here m2 u2 and minus m1 u1, minus m1 u2 is there. So I will take u2 as a common. So m2 minus m1, and here v2 is a common here. The v2 I am taking outside. So v2 is equal to m1 plus m2. Sorry. So now my equation will become this m1 m2 I am sending here. So this will come in a denominator side. So this is 2 m1 u1 divided by m1 plus m2 plus u2 is equal to m2 minus m1 divided by m1 plus m2. m1 plus m2. So this will becomes v2. Yes, we have done. So we have calculated another formula. So that is the velocity of the second object. So this velocity of the second object depends on the masses of both the objects and initial velocity of the both the object. So here main important for part for CET or a NEET is suppose when the two masses are equal, whatever this m1 object mass and m2 object masses are equal. So this is important for competitive part. So this is for competitive part. So when these two masses are equal, then what will be the velocity of a v1 object and what will be the velocity of the v2 object? So this v1 equation is, v1 is what? V1 is nothing but m1 minus m2 is multiplied with the initial velocity u1 and plus 2 m2 u2 divided by m1 plus m2, and here is m1 plus m2. So when these two masses are equal, then what will be the velocity of v1? See, this v1 will becomes this m1 minus m2, both the masses are equal, means this term will becomes a 0, and here 2 m2 u2 divided by this m1 plus m2 will becomes a 2 m2. So 2 m2 2 m2 cancel. So what I will get is u1 is equal to u2. See this. velocity of the first object velocity of the first object after collision will becomes the velocity of the second object. So velocity of the second object before collision, velocity of second object before collision. So if both the masses are equal, then v1 will becomes equal to u2. And similarly, for a second equation, for a second equation, that is v2 is equal to what? This v2 is equal to 2m1 u1 divided by m1 plus m2 plus m2 minus m1 into u1 divided by m1 plus m2. So this m1 is equal to m2 is there, so this will becomes a cancel, this will turn to 0. So what I will get is 2 m1 u1 divided by 2 m1. So this is cancel. So what I will get is v2 is equal to u1. So what it is suggesting, what it is representing is that the velocity of a second object becomes equal to velocity of a first object, first object that is before collision. This is velocity of the second object after collision. So to remember these two equations, that is v1 as well as the v2, see here the both are representing similar quantities. In the denominator side, m1 plus m2 will be there on both the cases, even v1 as well as the v2. M1 plus m2 is there, and here there are 2 m2 u2 on a v1 side. So in the v2 side, what is there? 2 m1 u1. So this we are replacing. If we replace 2 m2 u2 by 2 m1 u1, and here in the equation m1 minus m2 into u1 is there, and here is m2 minus m1 into u2 is there. Sorry, I have written wrongly here. So this is u2. So the denominator cases in both the cases are same. So if there is a v1, then we are adding a m2 object before a collision, and we are subtracting the masses and multiplying with the initial velocity u1. And in v2 cases, what we are doing, see this denominator m1 plus m2 is a common here. We are just adding a first object and their initial velocity, means we are adding the momentum of the first object, and then we are subtracting the two masses and we are multiplying with the velocity of the second object. So this is the collision in a one dimensions. Derivation is over, and in the next class we are going to study on the collision in a two dimensions. Thank you.